Thank you for that, and thank you, Sarah. So definitely we need a magnifying lens. So as you heard, this award is all about the world's smallest machines, the world's tiniest machines. And you can actually see an example of such a machine in this little picture. This is a microscope image. And you can not only see it, you can also see it moving, as you can see here. And they are really very tiny, these structures, only a few nanometers in length. And as you heard, as a comparison, a strand of hair is more than 1,000 times thicker. So really the tiniest possible machine you can experience. So how can you make these machines? Well, as Sarah very cleverly explained to you, one very important breakthrough in this area came in 1983 when Pierre Sauvage and his group made a so-called molecular chain. And the way they did this is that they constructed a molecular ring, and this is symbolized here in blue, and they had a molecular crescent-shaped molecule here in red, and you can see the chemical structures here on the side. And when you mix those two structures together with a small copper ion, the copper ion can act as a type of glue, gluing those two pieces together in a type of complex like this. And what you then can do is that can you add a third component, another red component here, you can see the structure over here, and then you can stitch them together chemically. And what you then will get after you remove them, the copper ion, is a type of molecular chain type of structure, also known as a catenane. And here you have a type of mechanical bond where the two rings can move freely relative to each other, but cannot come loose from one another. So it's a type of mechanical bond. This opened an entire field of molecular machinery, and it also reinvigorated another field, which is called topological chemistry, where you actually study very complex situations like this. What Jean-Pierre Sauvage and his group also realized at this point was that here you have what is called translational isomerism, because in the presence or in the absence of metal ion here, you have a large shift in shape in the structure, up to 1 nanometer change in shape.